Good morning students. This is third part of the fifth chapter inside the atom. Today we are going to learn about valency. The capacity of an element to combine with another element is known as valency. It is also defined as the number of chemical bonds formed by an atom. But why atoms combine with other elements or form chemical bonds? Let us find out. Chemical bonds are attractive forces that hold atoms together in the form of compounds. Chemical bonds are formed when electrons are shared, gained or accepted by an atom. But why atoms need to combine with each other? Atoms combine with each other to achieve stable state. The atoms become stable when their outermost shell is completely filled with electrons. For example, if an atom has only one shell, then the stable state can be achieved by completing duplet, that is, two electrons in the outermost shell or K shell. As electron holding capacity of K shell is only 2, it do not need any more electron to get stability. When the atom has 2 or more than 2 shells, stable state is achieved when the outermost shell contains 8 electrons. It is also called as octet. The concepts regarding valency of an element and chemical bonds in compounds get clarified from the electronic configuration. You can easily find valency of the element if you know electronic configuration of that atom. For example, electronic configuration of hydrogen is 1 and oxygen is 2, 6. So how we can find out valency of these both elements? Configuration of hydrogen is 1. It means it has only one electron in its outermost shell and need only one electron to complete duplet. It means valency of hydrogen is 1. Electronic configuration of oxygen is 2, 6. It means it needs 2 more electrons to complete its octet. This shows that its valency is 2. Atom forms chemical bonds by using electrons of outermost shell. For example, in water molecule, hydrogen form one chemical bond with oxygen atom and complete its duplet, whereas oxygen form two chemical bonds with two different hydrogen atoms and complete its octet. This also shows that valency means the number of chemical bonds formed by an atom. Because here valency of hydrogen is 1, so it forms one chemical bond with oxygen atom, and valency of oxygen is 2, so it forms two chemical bond with two different hydrogen atoms. Valency of an atom is determined by the configuration of its outermost shell. Therefore, the outermost shell is called as valence shell. Also, the electrons in the outermost shell are called as valence electrons. Do all the atoms carry valence electrons and they combine with other elements? Let us find out answer to this question. Look at the electronic configuration of elements helium, neon and argon. Most of these gaseous elements do not combine with any other atom. These elements are chemically inert. It means that their valency is 0. Helium atom contains 2 electrons which are accommodated in the first shell K. Helium has only one K shell that contains electrons and the same shell is the outermost shell. The electron capacity of K shell is 2. This indicates that the outermost shell of helium is completely filled. It means it has electron duplet. Atoms with electron duplet or octet do not take part in chemical reaction, so they are called as chemically inert atoms. Electronic configuration of the inert gas neon contains two shells, that is shell K and shell L. L is the valence shell of neon as it is its outermost shell. The electron capacity of L shell is 8, and in the neon there are 8 electrons in the outermost shell. It means it has completed its octet. Hence, neon is chemically inert as its outermost shell is completely filled. Argon is an inert gas or noble gas having electrons in the shell K, L and M. The electron capacity of the M shell is 18. However, in argon there are only 8 electrons in the valence shell M. It means that there are 8 electrons in the valence shell of inert gases. That is an octet. From this, it is understood that the valency is 0 when electron octet or duplet is complete. The The electronic configurations of elements other than inert gases show that they do not have electron octet or their octet is incomplete. Regarding hydrogen, it can be said that its electron duplet is incomplete. Atoms of all the elements except inert gases have tendency to combine with other atoms. It means they have non-zero valency. The electronic configuration of hydrogen shows that there is one electron less than the complete duplet state. It is seen from the formulae of the molecules formed by combination with hydrogen that valency of hydrogen is 1. For example, in hydrogen molecule, one hydrogen atom combines with another one hydrogen atom. In HCl, that is hydrochloric acid, one hydrogen atom combines with one chlorine atom. The electronic configuration of hydrogen atom shows that there is one electron less than the complete duplet state. This number 1 matches with the valency of hydrogen, which is also 1. Electronic configuration of sodium is 2, 8, 1. It has one electron in the valence shell and the valency of sodium is also 1 as seen from the molecular formula of NaCl, that is sodium chloride, where one sodium atom is bonded to one chlorine atom, and NaH, that is sodium hydride, where one sodium atom is bonded to one hydrogen atom. It means that there is some relation between the valency of element and the number of electrons in its valence shell. The table shows molecular formulae of compounds formed by some elements. Write the valency of the respective element obtained from them and also their electronic configuration and the number of their valence electrons in the empty spaces. Let us start completing the table. First is hydrogen. Symbol of hydrogen is H. First compound is HCl. It is hydrochloric acid. Valency of hydrogen is 1 because here one atom of hydrogen is combined with one atom of chlorine. Therefore, valency is 1. And electronic configuration of hydrogen is 1. Hydrogen contains just one electron in the outermost shell, so that valence electron is 1. Second element is chlorine. Its symbol is Cl. Chlorine and hydrogen combine to form compound HCl, that is hydrochloric acid. Here just one atom of chlorine is combined with hydrogen. Hence valency of chlorine is 1. Electronic configuration of chlorine is 2, 8, 7. Chlorine contains 7 electrons in the outermost shell. Hence valence electrons are 7. Means X is equal to 7. So 8 minus 7 is equal to 1. Next is neon. Neon do not combine with any atom and so its valency is 0. Electronic configuration of neon is 2, 8. Number of valence electrons are 0 as octet is complete there. Next is fluorine and compound which it form with the hydrogen is HF, that is hydrogen fluoride. Here just one fluorine atom is combined with hydrogen. Hence valency of the fluorine is 1. Its electronic configuration is 2, 7. It contains 7 electrons in the outermost shell. Hence number of valence electron is 7. So 8 minus 7 is equal to 1. Number 5 is sodium. Symbol is Na. Compound which it forms with the hydrogen is NaH, that is sodium hydride. As only one atom of the sodium is combined with the hydrogen, hence valency of the sodium is 1. Its electronic configuration is 2, 8, 1. It contains 1 electron in the outermost shell. Hence, number of valence electron is 1. So, 8 minus 1 is equal to 7. Number 6 is magnesium. Its symbol is Mg. Magnesium combine with chlorine and form compound MgCl2, that is magnesium dichloride. Here, 2 chlorine atoms are combined with one magnesium atom. Hence, valency of magnesium is 2. Its electronic configuration is 2, 8, 2. It means there are 2 electrons in its outermost shell. Hence, number of valence electron is 2 and 8 minus 2 is equal to 6. Number 7 is carbon. Its symbol is C. The compound which carbon form with hydrogen is CH4, that is methane. As here 4 hydrogen atoms are bonded to one carbon atom, it means valency of the carbon is 4. Its electronic configuration is 2, 4. It means there are 4 electrons in its valence shell. Hence 8 minus 4 is equal to 4. Last element is aluminium. Its symbol is Al. Compound which it forms with the chlorine is AlCl3, that is aluminium trichloride, as 3 chlorine atoms are bonded to one aluminium atom. Hence valency of the aluminium is 3. Its electronic configuration is 2, 8, 3. There are 3 electrons in its outermost shell, means the number of valence electrons are 3 and 8 minus 3 is equal to 5. Now from this table, observe the column which shows valency of the element and the column which shows number of valence electrons, that is X. It shows that when the number of valence electrons in an element X is 4 or less than 4, then number of valence electrons matches with the valency of that element. Now observe the column which shows valency of element and the last one which shows the value of 8 minus X. It shows that when the number of the valence electrons in an element X is 4 or more than 4, then 8 minus X matches with the valency of that element. 8 minus X electrons are used to complete the octet. The next topic which we are going to study is isotope. Meaning of the word isotope means having the same place, and this word came from the Greek words where isos means equal and tops means place. The term isotope was introduced by the British chemist Frederick Soddy in the year 1913. All of you know that atomic number is the total number of protons present in the nucleus of an atom, and atomic mass number is the total number of protons and neutrons present in the nucleus of an atom. Atomic number is the fundamental property of an element and its chemical identity, because atoms of different elements have different atomic numbers because their nuclei have different number of protons. Thus, atomic number of each element has certain characteristic value and no two elements have the same atomic number. But some elements in nature have atoms with same atomic number but different mass number. Such atoms of the same element having different mass number are called isotopes. For example, carbon has 3 isotopes, namely C12, C13 and C14. The mass number of isotope is also represented by another method as C12, C13 and C14 as shown in the picture. The isotopes have same proton number but different neutron number, and that's why their atomic number is same but their mass number is different. So here all 3 isotopes of carbon contain 6 protons in their nucleus, and that's why their atomic number is 6. But carbon 12 isotope has 6 protons and 6 neutrons, hence its atomic mass number is 12. In carbon 13 isotope, there are 6 protons and 7 neutrons, hence its atomic mass number is 6 plus 7 equal to 13. In carbon 14, there are 6 protons and 8 neutrons, hence its atomic mass number is 6 plus 8 is equal to 14. In this way, there are 3 isotopes of carbon found in the nature. There are 3 isotopes of hydrogen, that is protium or the normal hydrogen, then deuterium and tritium. From this, deuterium is also called as heavy water, which is used as coolant in the nuclear reactor. Heavy water means the water that contains deuterium in place of regular hydrogen. Chlorine also have 2 isotopes, that is chlorine 35 and chlorine 37. Radioactive isotopes. Isotopes of some elements are radioactive. It means their nuclei are unstable and spontaneously emit out radiations in the form of alpha, beta or gamma rays. They are used in various fields such as medical, agriculture, industry and in the research field, etc. Radioactive isotope sodium-24 is used for detection of cracks or leakage in the underground pipes. Some radioactive isotopes like cobalt-60 are used in the medical treatment of fatal diseases like cancer. Goiter, a disease of thyroid gland, can be treated with the help of iodine-131. Uranium-235 is used for nuclear fission and production of energy. Radioactive isotopes are used to preserve food from microbes. The radioactive isotope C14 is used to determine the age of archaeological objects. Nuclear reactor. Nuclear reactor is a machine that generates electricity on large scale by using atomic energy. In a nuclear reactor, the nuclear energy in atom is released by bringing about nuclear reaction on the nuclear fuel. Let us understand a nuclear reaction with example of a nuclear fuel, namely uranium-235. On bombardment with slow speed of neutrons, the nucleus of the isotope uranium-235 undergoes nuclear fission to form nuclei of two different elements, krypton-92 and barium-141, and 2 to 3 neutrons. On decreasing the speed, these neutrons bring about fission of more uranium-235 nuclei. In this way, a chain reaction of nuclear fission takes place. A large amount of nuclear energy is released during a chain reaction of fission. Nuclear fission is a process in which the nucleus of an atom splits into two or more smaller nuclei. The chain reaction is kept under control to prevent the probable explosion. To control the chain reaction in the nuclear reactor, it is necessary to decrease the speed and the number of neutrons. For this purpose, the following provision is made in a nuclear reactor. Number 1. Moderator. Graphite or heavy water is used as moderator for reducing the speed of neutrons. Second, controller. To reduce the number of neutrons by absorbing them, rods of boron, cadmium, beryllium, etc. are used as controller. The heat produced in the fission process is taken out by using water as coolant. Water is transformed into steam. By means of this heat, turbines are driven and electricity is generated. In India, total 22 nuclear reactors in 8 places are functioning. Apsara at Bhabha Atomic Research Center in Mumbai is the first nuclear reactor in India which went critical on the 4th August 1956. India has large reserves of the element thorium-232. Therefore, Indian scientists have developed a future plan for nuclear reactors based on production of the isotope uranium-233 from thorium-232.